On October 20th, 2025, the astronomy world was shaken by a single image. Amateur astronomer Carla S. captured something no one had predicted: interstellar comet 3I/Atlas appearing without its expected trailing tail, instead displaying a narrow jet aimed directly toward the sun. For decades, comet science followed a simple rule: tails always extend away from sunlight, shaped by radiation pressure and the solar wind. But S. raw, time-stamped frame, verified by coordinates and metadata from northern Chile, defied that model entirely. Her setup wasn't professional-grade NASA hardware, just a 150mm refractor with an H-alpha filter, yet it captured a precisely aligned, sunward jet that has since passed multiple artifact and calibration checks. It wasn't a glitch, reflection, or hot pixel. It was real and reproducible. Normally, comets display two distinct tails, a curved dust tail and a straight ion tail, both driven anti-solar. Even when geometry tricks the eye, projection effects never produce a tight, column-shaped beam pointing toward the sun. Yet Est's image did. Atmospheric logs confirmed excellent seeing conditions. Star points remained sharp and circular, no smearing, no optical error. If this were a visual illusion or stacking artifact, it would distort everything in the frame, not just the comet. Further analyses modeled Earth's position relative to Atlas's orbital plane, close, but not close enough for a true anti-tail illusion. The geometry simply didn't fit. Spectral data deepened the puzzle. Earlier readings showed an extreme CO2 to H2O ratio near 8:1, far higher than normal comets, suggesting unusual volatile chemistry. Some spectra even hinted at nickel without iron, a ratio unheard of in known solar system bodies. If confirmed, this would indicate material composition unlike anything naturally formed nearby. At the same time, the faintness of the coma, the gas halo, contrasted with a sharp sunward jet, behavior inconsistent with any known sublimation model. Every natural explanation faltered: projection, transient venting, differential sublimation, exotic ices. None fully matched the data. Theories now span from exotic natural chemistry to more speculative notions: a directional outflow mechanism, possibly serving as thermal control or vector stabilization, concepts familiar to engineers but foreign to natural bodies. Yet extraordinary ideas demand extraordinary proof. For now, the evidence remains tantalizing but incomplete. As 3I/Atlas races toward perihelion on October 29th, it will slip behind the sun, invisible to ground-based telescopes, monitored only by SOHO and Parker Solar Probe. This hidden phase is critical. If the jet vanishes or new structures emerge afterward, we'll know whether it was a transient vent or something more deliberate. By early November, as the comet reemerges from solar conjunction, astronomers will compare photometric changes, tail development, and trajectory shifts. Any consistent formation, any repeat of that sun-facing jet, could rewrite not just comet physics but the boundaries of what's possible in our solar system. For now, the facts are simple and unsettling. One verified observer, multiple independent analyses, and a jet that breaks every rule. The countdown to perihelion has begun, 8 days for the universe to show whether 3I/Atlas is a cosmic anomaly or the first sign of something we've never seen before.